Hi, Assalamualaikum and a very good evening. So today we guys want to do a presentation about assignment 2 from BMKM 3333 Maintenance, Diagnostic and Troubleshooting. So for this assignment we are choosing the cooling tower diagnosis for our title, and our lecturer is beloved TS Dr. Nur Azazi bin Ngatiman. So that's next, this is our team member. So the first one is Sugandhan anak lelaki Armugam, and the second one is Jayakuhan anak lelaki Ravi, and third one is me myself Muhammad Irfan bin Bakar Ali, and last one Muhammad Arfan bin Karim Muhammad. Next, here are the isi kandungan for this assignment. Firstly, we will start from the introduction and followed by the symptoms, damage mechanism, the causes of the problem, the corrective action for the causes, and preventative method, and lastly for the conclusion. So let's start. Okay, for the introduction, the cooling tower is one of the most important device in industries. For example, when the hot water come from heat exchanger, we use the cooling tower to cool it. The purpose of cooling tower is to cool relatively warm water by contacting with unsaturated air. The evaporation of water mainly provides cooling. In a typical water cooling water tower, warm water flows countercurrent to an air stream. Typically, the warm water enters the top of packed tower and cascades down through the packing, leaving at the bottom. So here is shown some of the how does it works, and where the air is in, where is the air is out, all of that. Next, for the symptoms, the first symptom we will see is water loss or leakage, and the symptoms we can see by visible water leaks from the tower body, piping or basin. So the frequent need to replenish water levels. For the second symptom, high energy consumption, the symptoms are increased power usage by cooling tower fans, pumps or auxiliary systems. And finally, the third symptoms are reduced cooling efficiency. Symptoms are higher than expected outlet water temperature, inability to maintain target process temperatures, increased energy consumption by connected system, for example chillers. Next.
Hi doctor, I'm Jayakuhan Ravi. Now I'm going to talk about damage mechanism in cooling tower. The cooling tower's pipes and valves are causing leakage, possibly due to damaged gasket in flank connections, valve seat, the wear or failure of valve stem packing, and causing leak around the valve stems. Cooling towers, along with their fans and motors, can experience various damage mechanisms that can significantly impact their performance and longevity. One common issue is misalignment, which can arise from improper installation or assembly and be exacerbated by vibration due to unbalanced blade or component. The effect of misalignment include increased vibration leading to structural fatigue, as well as reduced fan efficiency and higher energy consumption. Another prevalent problem is bearing failure, often caused by contaminated lubricants along with overloading or improper alignment of the shaft. Now I'm going to talk about causes of failure in cooling tower. Cooling tower failures can often be attributed to several key issues. Water dissipation failure may occur due to blocked or occluded nozzle, resulting in uneven water distribution. Mechanical failure can arise from worn out or damaged components such as fan blade, motors, gearbox, or belt drive. Additionally, structural failures may be caused by corrosion, material fatigue, damage to framework or fill material. Lastly, airflow problem can lead to inefficiencies, often stemming from obstructions in air pathway, improper fan speed, or poor maintenance practice. Addressing this potential cost is essential for maintaining optimal cooling tower performance.
Hi doctor, my name is Sugantan. Now I want to present about the corrective action in cooling tower. The corrective action number one is noise problem. The problem is excessive noise from fans or water flow. The corrective action is inspect and tighten loose component, replace worn bearing or other mechanical parts. The last is consider sound absorbing materials or barriers around the cooling tower. The second corrective action is mechanical failure. The problem is failure of fans, pump or motor. The correction action is implement a preventive maintenance program, replace or repair malfunction equipment promptly, maintain proper lubricant of moving parts. The last corrective action is overheating. The problem is inability to maintain deserved temperature. The correction action is check the blockage in the air inlet, ensure that fans are operating correctly and at the right speed. And the last one is evaluate the load on the system to confirm it does not exceed capacity. Now I want to present about the preventative maintenance. Preventative maintenance in cooling tower is essential to ensure efficient operation, minimize downtime and extend equipment life. Now I'm going to present about the preventative maintenance tool. The tools that using for preventative maintenance is laser alignment tools. The explanation is for precise alignments of shaft, motors and pump. The second tool is vibration analyzer. The explanation is to detect imbalance, misalignment or bearing issues in fans, motor or pumps. The third is multimeter. The explanation for the multimeter is for measuring voltage, current and resistance in electrical circuit.
Okay, next, standard procedure to diagnose cooling tower. So we have three standard procedure, that is daily maintenance, weekly maintenance and monthly maintenance. So first, daily maintenance. So daily maintenance, we need to inspect the water level, monitoring operating conditions and assess water quality. For the weekly maintenance, we need to inspect and clean the basin. We need to inspect the distribution system, check the fans and examine the drift eliminators. For monthly maintenance, we need to check the mechanical components, water treatment and inspect the failed material, and lastly is verify system controls. Okay, I will move to the conclusion. So the conclusion is in order to maintain system lifetime and operating of efficiency, cooling towers are essential for extracting heat from HVAC and industrial system. Failure may result from issues they encounter, tough, including corrosion, scaling, falling, and biological growth, mechanical wear and environmental effects, poor water quality, poor maintenance, bad construction and environmental conditions are the main underlying causes of these problems. To minimize downtime and increase the cooling tower's lifespan, routine cleaning, inspections and preventative maintenance are essential. Using long-lasting and corrosion resistant materials, improve dependability under challenging circumstances, while efficient water treatment is crucial to reducing scaling, falling, and corrosion. Freezing and structural damage can be avoided by adjusting to climatic circumstances such as winterization in cold locations, sustainability and financial savings. Okay, thank you.